GCSE Computer Science video covering programming techniques with me, Mr Goff, from mrgoff.com. Today's video will be focusing on programming style. Often overlooked or undervalued, programming style is all those little things a programmer does to make their code more friendly for updating and for testing. It includes things such as using sensible naming conventions, including meaningful comments in your code, using subroutines with well-documented interfaces, using error trapping to prevent runtime errors, using indentation to highlight data structures, and aiming for clarity over cleverness. The two most common naming conventions for naming your variables are snake case and camel case. Snake case is where all the letters of the variable name are lowercase, and when there's more than one word, they're joined with an underscore. Camel case starts with lowercase, but every new word starts with an uppercase letter. As well as following these conventions, names should always be meaningful. That is, we should be able to tell what will be stored in the variable from the name it's given. By convention, constants should be given capital letters in their name, so that any future programmers realise that these are supposed to be constant values. Comments are lines in your code that explain what it does. They are not executed when the code runs. Different languages have different methods for implementing comments. At this stage in learning computer science, you're probably still writing very short and simple programs. But the reality is that most programmers work on large programs and their code will be overseen by others and edited and maintained by different programmers. A really amusing thing someone once pointed out to me when I wasn't writing enough comments in my own code when I was learning to code was this comment: always imagine the person who will eventually edit your code is an absolute psychopath that knows where you live, i.e. comment your code so they don't come round to your house looking for you. Designing programs to work as a series of subroutines is a very good idea. It helps us to decompose the problem and allows us to solve a set of simpler programming challenges rather than one large challenge. Many programming languages have useful built-in subroutines, such as ones to generate a random number between two distinct values. To be able to use these, a programmer needs to only know the interface for these particular subroutines, that is, the values it needs to give it and what they will return. Error trapping involves trying to prevent users making errors and helping them to correct them when they do. The biggest problem we face are runtime errors because they stop a program from working. Many runtime errors are very predictable and therefore can be planned around. This includes doing things like checking a value we received is a number before we try and use it in a sum, making sure we're not about to divide by 0 before we perform a calculation, checking that a file with a certain name exists before we try and open the file with that name. To support this, most languages offer a try-except structure. This gives us a possibility to set up some different code to run if the program encounters one of these types of errors. Some languages, like Python, require indentation as part of their syntax for the code to run. For other languages, this should still be done as best practice. It makes the code far more readable and is easier to see. You should be able to see things such as the different structures, iteration and selection, and where there's nesting taking place. Making effective use of white space can also help your readability. For instance, leaving a blank line between each of your subroutines. It can be tempting to develop really complicated solutions to subroutines you're creating. However, as we mentioned earlier, it will often be the case that you'll be working on them with teams and that someone else will be the person that has to maintain and update your code. For this reason, it's best to keep to the K.I.S.S principle. That is, keep it simple, stupid. It's better to favour understandability of your code over creating some really clever structure that the next person might not understand when they come to update it. That brings us to the end of our video on programming style. Developing good habits in terms of your programming style is extremely important and something you should look to do while you're learning to code. I've been Mr Goff for MrGoff.com. I hope you'll join me again soon for another video focusing on trace tables. Bye for now.